Okay, so let's look at example number 10, another soil strength problem. Same thing, you can pause the video and work on the problem for a couple of minutes and we'll be back. Okay, so now we're back. We have a dry sand and we do know the principal stresses when this sample fails and asking for the friction angle. So this one is very interesting as well. But whenever you see we have principal stresses, and then the problem tends to become a lot easier. We have two principal stresses that we would usually use the smaller one as sigma 3, which is this 140 kPa over here, and the larger one is sigma 1, that is 300 kPa. So to solve this problem, and probably you can use a Mohr-Coulomb circle, and I love Mohr-Coulomb circle because those are just beautiful and very elegant graphs for you to solve problem, right? And the principal stress means that for the principal plane, you only have a normal stress. You don't really have any shear stress. So we would have a sigma 3 here, which is 140, and we have 300 or our sigma 1 here. So you know what? I'm just going to go and use all the numbers just to make everything a little bit easier. Okay? Again, principal stresses, the principal plane does not have any shear, so all the shear stress is basically 0. Okay? So you have the sigma 1 and the sigma 3, and now you can go ahead and construct a Mohr circle. Technically half a circle. And the center of the circle would be the center of the 140 and 300. And so this one over here is 140 plus 300 over 2. That would be 220. Okay? So after you have the Mohr circle, and you can try to construct the Mohr-Coulomb envelope. And the same thing, this is a dry sand as the previous one. And we know that if we're talking about dry sand, we can consider the cohesion to be 0, right? So cohesion 0. So if you have a 0 cohesion, then your failure envelope will go through the origin of the coordinate system and also at the same time be tangent to the Mohr circle, right? Because we know that under this 140, under this combo of 140 and 300, the soil has failed. So we have a tangent relationship over here. If we have a tangent relationship, we know that, okay, over here, we would have a 90 degree. So now the question is, what is the friction angle? So basically now this whole question becomes a very simple trigonometry problem, right? And we already know the length of this is 220. If we can figure out the radius of this circle, which is essentially 300 minus 140 over 2, and that is 80. And you look at the friction angle, you know this is 80, you know this one is 220. Basically, your sine friction angle would be 80 over 220. And this is 0.364. Your friction angle is arcsine 0.364, and you're talking about 21 degrees. So the correct answer is B. Okay? Yep, that's it for example number 10.